Hello, if you go back in this thread you'll show that I've put quite a bit of information together showing how a lack of oil feed to the clutch plates in these bikes has caused problems. This is your typical clutch hub. On here is a ring, and in the middle of that is the thrust bearing, but behind there, with it removed, this is the actual shaft here that the oil comes down, or more correctly, oil comes down the middle of this shaft, only in very small amounts. Obviously the shaft's not there, I would have to bring the whole bike to a bench, but in the middle of that shaft we're typically finding there's this thing called the thrust adapter. It takes the load that the hydraulic cylinder presses on the outside, pushes on the end of there, pushes the ring down here, and the ring pulls the pressure plate through and clamps the plates up together. The original problem I came across was that clutches were coming to me with sometimes no lining at all on the plates, and yet on the other side perfectly good, unworn, and it's purely down to a lack of oil reaching that particular face. Now the solution was to improve the oil flow out of the middle of here by making grinding modifications to this thrust adapter. You can see it's already got, this one anyway, has got 3 flats in its outer diameter. The early ones had 1, so BMW have increased that. Later ones have got 3 deep grooves machined down there, so there's a serious amount of oil getting out through the middle and down the face here to the holes, these holes which actually take oil from the central bore of the clutch hub out to the clutch plates themselves. So it's the position of each one of these in relation to the plates is quite critical, and this is one of the very early ones where the holes for the plate against the aluminium face there were nothing like near enough, and this isn't a plate out of this one, but that's eventually what the plate in this particular clutch would have started to look like. Now this is also one of the hubs out of the early bikes where instead of having a thrust adapter with a tail on like this one, the thrust adapter was cut off there. Well, I say cut off, it was never made with a tail on. It sat in the middle of the release bearing here, pushing the clutch undone with the hydraulic cylinder on the outside pressing on here. The earlier ones before that, without the tail, had an aluminium plug made in the end of the steel shaft. So here you would see typically a large nut, which was what holds the whole assembly onto the shaft. You would see a bit of shaft stuck out the middle of the nut, and in the middle of the nut an aluminium plug. BMW in the early days gave advice to pull that plug out and put another plug in that had a larger diameter hole in it to let oil through. Now my purpose for drawing changes, developments and other things I've found out to people's attention today is that I'm sending out clutch plates to people to put new clutches in their bikes, as well as actually rebuilding clutch baskets as well. And I had a customer who wrote back to say he was trying to get rid of clutch drag. Now clutch drag is when the plates are sticking together. And they have been sticking together because of insufficient oil on the plates, and if this one hadn't lost all its linings it would show that it was covered in gum, real sticky, and it would be sticking to anything that it was pressed against for any long time, any length of time, or I should say. Now to try and separate the plates, we've seen quite a few different solutions from BMW over the years. This is the one with the green rings on the tangs. So these are some flexible material which is designed to sit around one tang and push on the 2 neighbouring tangs, so it creates a spring effect. The spring's completely gone out of this one, but there's a little bit there. But it keeps a spring effect, so it would have pushed this friction face here away from this steel face here. It wouldn't have done anything to separate that steel face and that one, but it would have worked to then separate this friction plate away from that steel face. So it was something made to push the plates apart, and they put one at 12 o'clock and one at 6 o'clock on every third plate, every third friction plate, to push them apart. It might have helped, it might not, but then in more recent times, increasing the oil flow out of the middle here, they have now set themselves a rod for their own back, or they did in the first instance. Any oil that is coming out the end of the shaft here and runs down these ribs or these spokes of this hub, then finds its way into these channels here, which are already cast in, and you can just see in the channels there are holes. So if you can see a hole there, if I put my finger down the back, no, can't get that one to wink at us. Perhaps I can this one. See, there's a good hole if I put my finger down the back there. So that's the route for the oil. Gets caught in this outer rim. Only a small amount of it will actually get into these channels here. Any surplus will collect here and run off down the outside. That's alright, but I had this guy write to me who said he'd actually drilled his own holes in the aluminium plug that was there in one of the earlier bikes, which was okay. He'd got lots of oil going there. He'd got problems with his clutch dragging. In actual fact, his clutch drag got worse. The problem was that he'd actually got too much oil going out of there. Well, not too much, except for the fact that the early versions of bikes, when this is in place, if we look at the diameter of this outer spring, it's 105 millimeters or thereabouts. So any oil going down there that hasn't fed into these will actually stand here in this area due to centrifugal force, because this is running at 2,000–3,000 RPM quite regularly when the bike's running with oil coming out there. It's working as a centrifuge, oil's thrown to the outside, and it will build up here. But fortunately, this face, because of the way that it is cast as a die casting, is slightly tapered. So if I stand it there, that from there to there is slightly downhill, so to speak. So oil, any oil there will actually work its way to the edge and down here. So then the next space for oil to get out of this assembly, you would imagine, is through these 6 grooves around the outside, which ironically are only there for the clutch hub holding tool to lock this solid while you undo the big nut in the middle. But if this spring makes a nice seal just there on the wire, which is a wire seat put in so that the actual toe of the pressure plate doesn't cut into the aluminium, that would be fine. But in actual fact, this spring is a good seal on this metal ring. The metal ring has one little gap in it there, which when it's in position is much smaller anyway. If the gap in the ring isn't lined up with the gap here, oil's still going to collect, and it's not going to get away out of this area here. So straight away you've built an unequal void, if you like, that's filling with oil due to centrifugal force. If you've got this lined up, some oil's getting out there, but the rest of the oil's around here. It's going to add weight here at this side, and then it's got to go all the way around here and all the way around here to get out. So it's going to create some imbalance. So whenever you do have one of these in bits, please make sure you, tricky thing, please make sure you always put the ring back in, so that the ends are within here. It can't get out then either. If something awful happens, it can't decide it's going to work its way out there. But the problem for this guy was that as I said already, the diameter here is 105 millimeters or thereabouts from here across to here. If we measure the inside diameter of here, it's a bit less. So the problem is, this thing was actually working as a dam to stop the oil that had collected in here getting out and away, or coming over this edge. Eventually it would come over these edges here, but there would be oil trapped in there, so it would have created a depth of oil all the way inside there. He had followed the good advice and put an additional hole there. I'm not quite sure he'd put it actually in the right place, which is as far to the opposite side of the clutch as you can possibly put it, than where the one is that's not near enough. But it was quite clear from his later experimenting that he was over oiling the clutch because the oil wasn't getting away. How do we know this? The bike used to start alright, it went into gear fine, there was very little or no clutch drag, the clutch plates were separating. He'd ridden only a short distance, not necessarily even long enough for there to be a change in temperature, and what we surmise is that this area here had eventually started to fill up with oil, not to a great depth, but it would only need a millimetre of oil in here, and due to the centrifugal effect, or centrifuge effect, it would be forcing oil out of these holes. They would be permanently fed with a serious feed of oil. And of course, when he pressed the slave cylinder into the middle of the thrust bearing to push the pressure plate away off the back here to release the clutch, the oil that was all trapped in these spaces and here would rush out, and it would actually be sticking his plates together even worse. So what he'd done, he'd created a mini torque converter, if you like, or certainly a mini limited slip differential type of thing for the middle of his clutch. As I say, his later experimenting sort of proved it really, because all he did was he went back in, he plugged all the extra holes he'd made in his aluminium plug there. I stress this is only relevant to the early bikes, and I'll show you how to tell the difference. Well, one obviously is that they have that aluminium plug, but people have chopped and changed these parts around on the bikes over the years. You never know what you're going to find, so you better check. Anyhow, he'd plugged his holes back up again. In other words, he wasn't feeding any oil out of the front here, and he was fine. He was back to normal. His clutch was disengaging. He'd still got the poor gear change, which is quite common on the bikes, which was the whole reason he was suspecting his clutch drag was the cause of. But he'd got no clutch drag then. He was actually then running some of my special plates that I get built up for the clutch in these bikes, and that was it. He was fine. So we started thinking about what could be the difference between some oil getting through and not, and this is what we eventually came up with, that this spring was working as a dam. I knew that there was a difference in the way that these 6 slots around the periphery were made, and here I've got a later one. This one you can see, or you may see, is made in 04. This later one is an 07. And if we look at the difference in the slots, you can see that the later one has a machined area past the slot for the spring seat to go in. You see the machined area there, but also you'll see that the slot itself on the later bike is quite a bit deeper. Well, it's not immediately obvious there, but when you look from here you can see that there's actually a gap in them. Ignore that, that's a mark from the casting process. I'll go to another one that's probably better. You can see the machined ring here, where they've had a lathe tool in that's cut this piece out, doesn't actually cut all the way across the end of the groove, and that's because this here is lower. They've actually created a drain point there. In fact, they've created 6 drain points. So they themselves quite likely became aware that the spring, and more likely the seat itself, get this back in, so bear with me. That one doesn't want to go in, I'll put this one in. The spring itself no longer touches the bottom of the slot, so you can see daylight through there. Now you can see it, now you can't see it, now you see it, now you don't see it. So there's an oil route out underneath the spring, underneath the spring seat. So when the spring's in place, even though we might be getting this weir effect, this damming effect, where the spring is behaving as a dam to oil flow, excess oil flow out of here and out of the way and not going up to the plates, we've actually got a root out now, or 6 roots out. So due to centrifugal force, well, in fact we can see you can better see the groove there now that this is in place. This groove goes all the way through and underneath, whereas on the earlier one nothing went through and underneath. So whenever you're improving the lubrication out of the middle of one of these, please have a look and make sure that you've got the later hub with the extra capacity to shift excess oil out of there, and then hopefully you won't end up over oiling the clutch, which is what this chap did, and turning it into a dragging clutch. Not as bad perhaps as standard, but as bad a dragging clutch as he had beforehand. And well, as he said, the bike wasn't fit to ride. You'd pull the clutch and it wouldn't disengage, so you get to the end of the road, pull up at the traffic lights or a roundabout, and you weren't disengaging. So that's why I draw it to people's attention. Make sure that you're not over oiling, or if you are over oiling, there's not really an issue as long as you've got these places. So while we're on the subject of oiling, most people I think are adapting their own thrust adapters, as I suggested earlier on. What I've found out is that this is a perfectly acceptable level of modification, or sorry, this is BMW's own modification. This is moving enough oil. I wouldn't be worried about having to try and increase the capacity of oil that came out along the shaft, down the outside of this, and then off there, down here, down the spokes to lubricate the hub. And while we're here, this particular hub, I've not cleaned it up. I've left it as it came out of the bike. Well, save a few finger marks, but you can see all the black marks here. That is proof that oil does sit in there and is subject to the centrifugal force, because this is bits of carbon deposits which would have just naturally occurred in the oil as a result of the engine's combustion process. They've been flung to the outside of here with centrifugal force and have stuck to the metal rather than washing away. So anywhere where there's been oil subject to centrifugal force, it's settled, the bits have settled out of it. This isn't somebody who had a bike that they didn't change the oil in regularly, that's just what happens. So we can see there against this spoke where there's been a particular puddle of oil, a good depth, quite a bit of dirt's collected. The same behind this particular spoke here, quite a bit of dirt's collected. Nice flat area there where it's collected. And if we look up the actual channels themselves, they themselves are quite black in the bottom as well, where due to centrifugal force, any oil that's been travelling along them has given up its dirt, given up its carbon content bits, and it's all stuck in the channels. All the channels are the same. If I can manage to get the light to do its job and shine all the way through for us. Perhaps next time I do this I might put a torch through or something. So that's the problem. We think that if there's too much oil there it might get out the back, or it would go all the way through these 6 feed slots, but in actual fact, of course, the back of the clutch, when the clutch is released and the engine's driving the bike along, the clutch is all clamped up. This is all sealed with clutch friction plates and clutch steel plates, and then the pressure plate itself makes a nice end cap as well, so not much oil will get up the gap between the end of the hub here and up here, and if it does, it's actually sealed by that face as well. So wherever the excess of oil was collecting in this central cavity for this guy who opened his plug up massively, the oil doesn't get away, it stays there. If you bear with me also, I can show you the other versions of stopping the clutch plates sticking together that BMW have employed over the years. This is the one where I showed you earlier with the green rings. The fundamental problem is the clutches weren't really wet enough. They made the steel plates too flat and too smooth. So what they built was something that stuck together, and I think this is the set of plates from the uncleaned up clutch. Now if I've just pressed them together, I'm only holding the steel plate here there is a friction plate on the back of this. Can you see the friction plate? I'm only holding the steel, but the friction plate's stuck on. And if I lean it this way, it'll probably slide on the oil. There we go. So we've got a friction plate on top, a steel plate, and then a friction plate underneath, and the friction plate underneath is stuck. I can show you that better by taking one friction plate out of the way. Show you that I'm purely holding the steel with expanding my fingers and thumb inside the steel plate, and there we are. This one is stuck, and that's how it will be while it's in the bike, while the clutch is driving the bike, or while it's parked up. As soon as you want it to separate, they're sticking. So that is BMW standard steel plate, BMW standard friction plate. This is obviously cold oil, but it is the oil that it came with out the bike. I've no reason to believe it's the wrong oil. That's just how they are. They stick, nice and sticky. They've attempted to get over that stickiness as well. While I was looking at a set of plates the other day, rather than doing what the Japanese do, and BMW finally did in the end when they started buying Japanese plates, the Japanese plates have these little pimples on, or little dints all the way around. These are holes, they are not stuck up, they are dints, and they behave like a tyre tread really. So they let oil get away, but also they break down the surface attraction of the oil on there when it's trying to have the plate stick to it. And I don't know if you can see this, but in one clutch that came, many of the friction plates had this treatment, and it's like a scoring that's been done at the factory on some kind of a machine. There is lines here, probably 1/8 of an inch apart. Those lines go across from one side right to the other, and then at 90 degrees to them is another set of lines, score lines, which actually score the surface of the friction plate. And I'll move that in, and you might just see the scorings very prominent on there. It's worn off or almost invisible on others. This friction segment here has more scoring. Don't know if you can probably see it there, yeah. So even quite late on, they were attempting to break the stiction problem with scored friction surfaces, and I can't believe that that's somebody taken this one to bits and done it himself. The lines are so perfectly parallel and such perfect 90 degrees to each other, and it's not the only plate like it that I've got out to show you, although I can't find the others that have it, but it's not the only plate that has it. Quite a lot of them are there. This is the other one. Here we go, more scoring. These two have sort of taken on a matte finish, and the scoring on them is quite prominent. If I turn this round anyway, the same scorings there. Now it appears to be just visible on every fourth one. In actual fact, that's because every fourth one has a different backing to it. You just see the circle there where the aluminium backing plate is dinted somehow, so it's just probably that segment stuck on there. There's better oil flow out the back of it due to oil leaking into the void left by the ring in the segment. So there we are. That's that's the German manufacturers. I think it must have been their first ever wet clutch. So that's the problem. As I say, the later plates from BMW are very much like these Japanese plates I have here. They've got the dimples in all over to reduce the stiction. They don't have the uber shiny ground finish that the German BMW plates have as well. They sort of matte, and again helps the plate become unstuck if it's been there a while in oil. This is the friction surface of the plates I've been supplying. Much the same design as the BMW stuff, and in actual fact what I'm supplying is a clutch with 9 frictions. The stock BMWs only have 8 frictions, so my plates are slightly thinner and the steel plates are slightly thinner. But what that does is it gives us one whole extra friction plate, in other words 2 sides of friction plate for more grip of the whole clutch as it takes up, creates as a slightly spongier, better feeling clutch as well. And because it's a proven arrangement out of that's used in many bikes, apart from BMW's quirky arrangement with the splining and the tangs, it's proven and it works very well, and it has done in many bikes for many years. So and even BMW have adopted it now, so must be something right there. It's taken them long enough. So I think that's it. So the main thing is, please don't assume that all your clutches are going to be as bad as that if they're misbehaving. They're not, but there will be signs of trouble if they're not the very latest clutches. And again, please be aware that you need to look to make sure if you've improved the oiling out of the middle there, or if you're mixing and matching bits from new clutches and old clutches to put yourself a decent clutch together, please be aware that there's that difference there, where we've got a leak for oil out that might be collecting as a reservoir, which would be too deep in here, rather than on the earlier ones where there is no leak at all. It's trapped there against the spring seat and then ultimately under the spring. I think that explains it all. Thanks very much. Amazingly, I've got away with that in one take. Can't believe it.